7, 6, 5, 4, 3, 2, 1.
Hey, everybody. Welcome to this episode of NASA in Silicon Valley Live for October 11th, 2018. I'm your host, Abby Tabor, and today we're going to be talking all about robotic exploration of the moon. And we have some really fascinating guests with us. But first, let me introduce my co-host, Cassandra Bell. Hey.
Hi. So this is NASA in Silicon Valley Live, a conversational talk show out of NASA Ames Research Center with the various scientists, engineers, and researchers and all-around cool people at NASA to talk about all the nerdy NASA news you need to know about. If you like that, we're simultaneously live on Twitch. That is twitch.tv/NASA. And we're also on Facebook and YouTube. And if you want to participate live in our chat, you got to catch us on Twitch. But if you miss the live show, we will be on demand after the fact on NASA TV, and we can also have the podcast for an audio version if you like that better. So today we have with us our guests Tony Colaprete and Kimberly Ennico-Smith. Thank you both for being here, and can you tell us a little bit about what you both do?
Yeah, hi, thanks. I'm a planetary scientist here at NASA Ames. I've been here about 15 years, almost exactly 15 years. And as a planetary scientist, I mostly study planetary atmospheres and surfaces, really focusing on ices and other volatiles that freeze out. I also design and build instruments that go to different worlds and make measurements of the atmospheres and surfaces and things like that.
Very cool. And Kimberly?
Well, thanks for having me. I'm a research astrophysicist here at NASA Ames, and I've been here for a little bit longer than Tony. I study the universe, and I also build payloads or instruments, cameras, spectrometers that help us understand the universe around us, both near and far. So I have dabbled a little bit in some of Tony's planets as well.
Very cool. Well, speaking of nerdy NASA news, NASA just turned 60. Yay! Happy birthday, NASA.
Should we sing?
Where's the cake?
Oh, there was cake.
Last week we had cake.
Yeah, I missed it.
It was
I
good.
missed it. I had a lunchtime meeting, and I think I missed the cake.
It's very good cake. Well, NASA turned 1 on October 1st, and that would 60 years would be October 1st, 1958.
Do you guys know what actually happened at that point? Because, you picture the president signed a thing and then NASA suddenly existed, or it was
his birth certificate.
It was his birth certificate.
Yeah, signing from a birth certificate.
It must have been built on earlier research labs that existed, right?
Yeah. And at the time, it was aeronautics was the focus of what the laboratories did. They weren't doing space research yet, but they were very heavily into understanding aerodynamics, aerospace engineering, and whatnot to help really the fledgling airline industry and aviation industry, doing the things that they couldn't do, helping them do the research they couldn't do.
And pushing the envelope, see what else you could do, by different designs.
Oh, yeah.
And that was the NACA, right?
Yeah.
Yes, don't call it NACA.
Okay.
No. Don't call it that. No, the National Advisory Committee for Aeronautics is what preceded NASA, right? And I've been scolded for calling it NACA.
We are NASA,
Yes.
but that was NACA.
That's right. Yes.
Yeah. And there were 3 centers at the time.
Right.
There was one out of Langley, Virginia.
On the East Coast.
Yeah,
and now that's Langley. What's it called now?
I went from the Langley Aeronautical Laboratory to the Langley Research Center.
That's right.
One in Ohio.
Yep. And
Which was, do you guys know?
I always forget this one. It was Vincent? No, what was it?
Lewis.
Lewis. Vincent Lewis. I was close. Lewis. And it's now, of course, the Glenn Research Center. I know that. Yeah.
And then our favorite.
Our very favorite, not biased.
I can't remember the third.
It's out here in California. Oh, the Ames.
You might have been there. The Ames Aeronautical
Laboratory. So now known as the Ames Research Center.
Where we are right now today.
Yes.
Of course. Yeah.
And now that we have 10 field centers doing all kinds of amazing work. So to learn about the last 60 years of innovation, go to nasa.gov/60.
Yeah. So in this episode, though, we're going to focus on the moon research, the lunar research that Ames has worked on over those years since NASA was founded. And if you have questions, be sure to leave them in the chat, and I'll be checking for those and trying to throw some of those in later. For example, already we have questions from Zazie Lavender, who's asking, what things will you be exploring on the moon? We're going to come to that. That's the heart of today's episode. So to kick things off, we're going to go to our first segment, Let's Play. Let's roll that. All right, it's time for Let's Play. This may include game controllers, 12-sided dice, or a Pop-Matic bubble. But basically, it's all an excuse to play games and talk about science. And so today, what we have is the Lunar Firsts Pop Quiz. Surprise!
Didn't know there was going to be a quiz today.
You're getting a quiz, and everybody watching, you can leave your answers in the chat, and we'll see how you fare. So I'm
It's a
going to
payload.
Yes, I'm going to ask a question, and there will be an image
cone.
on screen associated, and we'll see how you do. Okay, question 1 here. On March 3rd, 1959, the United States sent this spacecraft to the moon, successfully making the first U.S. lunar flyby.
So what was the year again? 59.
59.
So
59.
part of the Mariner series, right?
Well, the Mariners, they went to Venus and they went to Mars. Did they go to the
Yeah,
moon?
they did a flyby.
Did they? Okay.
It's not this guy. This is another.
Maybe a first person.
A trailblazing kind of
Like the Pony
spacecraft.
Express?
Oh, maybe like a pioneer.
And I know about the pioneers that went to the outer solar system, but we went to the moon as well. That's
I
cool.
think they did the flyby. So
Yep.
Yeah.
one of the earlier ones. Do you know the number too?
Well, for full credit.
Full credit.
But for partial, you got Pioneer. So this is Pioneer.
4.
Pioneer 4. Yes,
Pioneer
exactly. Very good. All right. Moving on to number 2. On October 27th, 1961, NASA accomplished the first successful test of this rocket, which shares its name with the family of rockets that would eventually take humans to the moon.
Wow.
This one's easier.
Yeah.
Yeah.
Well, the Upgrower 5, or Saturn 5, took us to the
Saturn
moon,
5.
so it must be the Saturn series.
It is. Yeah.
Single stage, Saturn 1.
Yeah,
Yes,
exactly.
ding, ding, ding.
First test.
Yeah.
Very good, very good. Saturn 1. All right. Question 3. Let's see what that looks like. On June 2nd, 1966, this spacecraft became the first American spacecraft to soft land on the moon.
I'd have to survey my answers.
Surveyor!
Surveyor!
I like being Surveyor 1.
It is. Surveyor 1. Excellent. And I have a fun fact here that Surveyor 1 transmitted more than 10,000 high-quality photographs of the surface of the moon
Wow.
as it went in for
And
landing.
the Surveyor series of these landers, this is before we had digital cameras.
Oh, yeah.
These are video cameras and film.
Oh,
And so
yeah,
you talk about how many photos?
10,000.
10,000
Yeah.
photos?
That's a lot of film.
That is a lot of, a lot of film.
I never think about that. Yeah.
It's a lot of
It was
film.
film back then. All right, one more question, number 4. On July 20th, 1969, this Apollo 11 astronaut became the first person to walk on the moon.
That's
People should know that.
Yes,
I
everyone should know
that.
this.
Yeah.
Neil.
That would be Neil Armstrong.
That is Neil Armstrong, exactly. Very good. So well done. You've passed your pop quiz. And
You burned your meatball. Your NASA meatball.
that's your prize. So if you're just joining us, we're talking about robotic exploration of the moon today. And before humans got there, before Neil, there were robots. So Cassandra, I think, is going to walk us through some of that history.
Yes. So it all started with robots. Actually, I think Tony's more of and Kimberly are experts on how this robotic exploration started.
Yeah, it started back in the late 1950s when a little orbiter named Sputnik went overhead and ushered us into...
Beep.
There it is. I hear it now.
Nick?
That's 92.6 minutes.
Yeah.
That's the orbiter on the Earth. So.
And it ushered in the space age. And with it, the exploration of the Earth from orbit, but also beyond the Earth. And as part of the space race to the moon, the effort between the United States and the Soviet Union to get to the humans to the moon first, there was a range of robotic missions that took the steps necessary to eventually bring humans to the moon and return them safely.
And talking about steps, you have to leave the Earth safely. You then have to get to the moon, so you have to be able to reach the moon. And then if you want to go in orbit around the moon, you have to be able to go and get captured by there's a lot of different steps to when you're starting to explore. So you can use these robotic, messengers to work out all the kinks.
Okay, so Sputnik started it, and then...
There were a few kinks.
Yeah.
There were a few kinks.
I mentioned some of those.
Gosh, we got out of the 50s, we got into the 60s, and what was next?
Well, so the first series with respect to the moon was the Ranger series. And that was, as Kim described, really just learning how to get off the moon or get off the Earth to the moon.
To the moon.
Yeah, and that was a challenging period. The first 6 Ranger missions had failures or problems to make them not fully successful.
Yeah, one of them missed the moon, but that was just, the rocket fired at a slightly different time, and the moon and the Earth are moving with respect to the sun.
I think we have a video.
Yeah, we do. We have video of Ranger 7 launching.
This was the first fully successful Ranger mission. Ranger 6 hit the moon intentionally, but its camera failed. The first 2 failed on launch. Others, the fairings didn't work. That's the part that holds the spacecraft. This one was first fully successful, and it did everything from teach us how to navigate to the moon, but also transmit data. So these are images of the moon as we go into crash. It's controlled landing, controlled hard landing, and it's beaming live television. Live from the moon, images for Ranger. So it was a really important series, and it was key because without doing that, being able to get to the moon, you can't do the next step.
Which is?
Go in orbit around the moon.
There you go.
Okay.
Yeah.
And then if you go in orbit around the moon, then you've shown that you can slow down your spacecraft that you've launched from the Earth and it's traveling really fast, and then control it to go and then even look at the moon and take pictures. Or perhaps you can look at something else.
Yeah. Well, speaking of that, I know one of your favorite images, right, is Lunar Orbiter 1.
Lunar Orbiter 1.
Yeah.
Spacecraft that was, we got our first image of our homeworld of Earth from lunar orbit, and that was from Lunar Orbiter 1. You're seeing it right now.
Oh, yeah.
Took place in August of 1966. And phenomenal. I mean, it's a perspective-changing photograph because this is us looking back at home from our nearest neighbor, the moon.
Yeah.
And you can see it's again a video camera, and they processed the film on board the spacecraft and sent it back. And that's also technology that had to be developed.
So they had to develop film on the moon.
Well, it's on the spacecraft from lunar orbit, and then sending it back. So then we get these amazing pictures of both the surface of the moon, but also looking back at the Earth.
Mm-hmm. So that one had stripy bands throughout it.
Yeah, those are the bands of film. So they actually had the TV camera go across an image, take TV motion picture of the film, and that's what was beamed back to Earth. So that's why it looks striped that way.
I see. But then you were telling me that this was reprocessed more recently here at Ames?
Yeah, there's a group of citizen scientists who take an interest in the history of NASA, and look at this beautiful picture you're seeing right now, digitally reprocessed. And so that's that same image from Lunar Orbiter. And, with today's computer techniques and looking at images, you can remove artifacts and maintain the image.
Yeah.
So, and some of our best images of the moon come from that period. I mean, you capture a lot on film. Really high quality.
Yes.
Wow. Yeah. I mean, down to the smallest of scales, to the dynamic range.
So we orbited the moon.
Yeah.
And then
next step,
there's another step after that.
Get to the surface. If again, the ultimate goal at this period was to land on the moon, land humans on the moon and get them back, we had to get to the moon and get to the surface, and not in the way Ranger did. That was a hard landing. And sometimes a crash.
Okay, but intentional.
But intentional. So the
Okay,
difference between a crash and a hard landing is one's intentionally.
One's planned.
Yeah, one's planned.
Okay.
So the next set of missions, Surveyor missions, really were intended to understand how to land on the moon softly and in a controlled way. Mm-hmm. And they taught us not just how to land, but how to land where you want to land. Because you don't.
That's another skill. Know exactly, where on the moon to pinpoint.
Yeah, we had these images from orbit. We knew we wanted to go to this place. How do I get a spacecraft to go to that place? It's easy now with GPS, right? You pull up your map app and
you just plug in the phone.
Yeah,
moon.
Exactly, moon. Yeah. Put in your coordinates. So there was all those technologies that they had to learn how to have the rockets not only slow you into orbit, but now slow you down so you fall out of orbit and do a controlled landing.
And that was to learn about, they were trying to learn about the surface?
Yeah, so one of the biggest questions at the time was how deep was the lunar dust? We knew there was a dust that covered the moon generated from meteor impacts, churning up the surface. There was all kinds of theories about it being very, very thick and very, very porous or fluffy.
Oh, really?
Like a deep powdered snow, if you will.
Oh, imagine that.
And so there was a real concern that
If you landed something on the moon,
You're gonna sink.
you could sink.
Like trying to walk in deep snow is just,
Walking in like
don't really
deep
get
snow.
very far.
Yeah.
right.
And if you're landing a spacecraft, maybe the feet just go straight down and you just fall over. The spacecraft falls on its side, whatever. So
The sending the robotic, before the humans came, answered a lot of those questions.
Yeah.
And we made us realize that, you can
can.
do
This
the
is
soft
doable.
landing. And in these places of the moon, you can land safely.
Wow. Yeah, I have a quick question from the chat. This is a fundamental moon question from Babu Kar. How old is the moon? As old as Earth?
it's yes.
Yes.
And nice round numbers.
Eight nice round numbers. It's one significant figure. As we like to say.
Yeah.
I mean, the origin of the moon is something that we're still trying to understand.
Exactly.
I mean, there are theories out there, and theories are only tested by observational evidence, and we don't have that time machine, a TARDIS, to go back in time to find the birth of the moon.
Right.
But the leading theory is that at some point during the early parts of our solar system, a Mars-sized object hit the early Earth and spun off what now has become our moon. And that's got a lot of observational evidence that we can support that. But we weren't there to watch it happen.
We didn't see it happen.
So it is quite old.
It could be then, if that theory is right, it's just a little bit younger than the Earth, but made largely, or in large part, of Earth material. So in a way, it is as old as the moon.
And this is one of the reasons why we
Or
want to
there-
study the moon, because it also tells us about our own origins.
Exactly.
Very much at a fundamental level.
And you talked about that Surveyor mission, trying to figure out how fluffy or not fluffy the moon is. Kimberly, you said one of your favorite pictures has Surveyor in it.
Oh, yeah.
Yeah.
Here's to bring this one up. This is from Apollo 12, and what you're seeing is astronaut P. Conrad walking up to Surveyor 3. In the background is the lunar excursion module from Apollo 12. They pinpointed exact landing to about 600 feet of Surveyor 3. And they did that deliberately for, of course, testing where you can land strategically.
See if they could do it.
But now they're going up and saying hello to the robot that came 2 years earlier and looking at the experiments that were on board and brought back equipment from the Surveyor. But there was a Surveyor that set the scale for, the landscape, and then we followed it with the humans. And I just think it's both logical and poetic when I look at this picture, because it shows that the robots help with the human exploration, and also, it's just beautiful. That's why it's one of my favorite images.
Yeah, there's a lot in there.
So after these Apollo missions, so we got to walk on the moon. We found out we wouldn't sink. What happened after Apollo? What was?
Well, Apollo 17 was the last mission that we flew, and one of the best. And it was 1972, and then after that, nothing happened.
Nothing?
Nothing.
It's the dark ages of lunar exploration.
Okay.
We went into a dark period.
Until
For NASA, it wasn't until 1994 that the United States returned to
22
the moon.
years, you said?
22 years.
22 years after the final Apollo mission.
Okay.
And that was the Clementine mission, which was a Department of Defense
Not the fruit.
spacecraft.
Those are good, though.
And,
Not the oranges.
and it had some NASA instruments. So it was a DoD spacecraft, but it had NASA instruments on it. But it's a really important mission because it tested a theory that had been outstanding or been put forward back in the late 1950s by Urey and others, that water could exist at the poles of the moon. Because the moon has a very slight tilt in its axis, much smaller than Earth's, craters at the poles have floors that are permanently shadowed. So it goes back to the question of when did the moon form. It goes back for these shadows have been at the bottom of these craters for as long as the Earth's been in its current obliquity.
They've never seen sunlight?
For 2 billion years
That's
or more.
so crazy. I haven't learned that recently.
And
It's
because
amazing.
they haven't seen sunlight and there's no atmosphere, appreciable atmosphere on the moon, they are cold. Minus 250 degrees below 0 centigrade.
Oh, that is
Which
cold.
I looked up. You told me that before, and it's like minus 400 Fahrenheit, I think.
Yeah,
It's cold.
it's really cold.
Okay.
And it's cold enough to trap all kinds of things, including water.
I brought my little moon model.
There's the moon.
It's my huggable moon model. It's a plush toy.
Very sweet. So
you
you're
think-
talking about the poles?
Yeah, and we were talking about the poles, the north and the south, and a lot of our earlier explorers had looked more around the equator, the tropics, you could say.
I always call
But
it
what
tropics,
was
they're not.
fascinating with the Clementine, and we learned that the poles are special places because of the moon is slightly tilted.
So
And,
what's special? There might be water, you said?
Yeah, so
Yeah.
there might be water trapped in these craters, and that was speculated back in the late 1950s. So the Clementine mission did an experiment to test this using radar, and they saw a result for a particular crater at the South Pole called Shackleton, and it suggested that there could be bulk water ice.
Really?
Problem is,
it was inconclusive.
it is inconclusive
because the
yeah.
results could have been explained by large rocks.
Oh, wow.
And, they couldn't tell the difference between the data. So what do? You have to...
Yeah, and then there was one other. You have to go. You have to return. You have to, like you said, you learn from your previous
learn from the
experiments, right? And you
yeah.
add to it. So that was tantalizing, not conclusive, but it inspired the next mission, which happened 4 years later, 1998. And this was a NASA-led mission, actually led by NASA Ames.
Right here.
Yeah, Cool. And it was called Lunar Prospector.
Oh, I think we have a model of that.
Yeah, we do. And but be careful; it's as old as
carefully.
the original spacecraft. So yeah, Lunar Prospector did exactly like its name suggests. It looked for certain compositions and really elements. What it did, out on these booms here, you see these long arms, were instruments that measured the surface composition. And one of the things it was looking for, one of the elements it was looking for was hydrogen. Now, why hydrogen? Well, there's two hydrogens in any water molecule you might have.
H2O.
H2O.
The H and H2O hydrogen.
So if there is indeed water at the poles of the moon, it might be able to see it in the form of an increase in hydrogen. And lo and behold, at the poles of the moon, it saw increases in hydrogen. And it didn't see it around the equator, which really did suggest there was something inherent about the qualities or conditions at the poles of the moon that was allowing this hydrogen to accumulate.
So we had to wait to the 1990s, right?
Yeah.
To actually get our first glimpse of a global chemistry of the moon.
Yeah.
And it raised more questions.
So Lunar Prospector did all of that, but this is, can you tell us more about what we're looking at here? This is a model of it, yes?
Yeah, it's a model. It's a very simple spacecraft. It's about, I think we have a picture of it. It's about the size of a human.
Oh, yeah.
Human
There you
size.
go.
Oh, here we go.
Yeah.
So there it is on top of the booster that helps put it into lunar orbit. So just the shiny blue part on the top is the spacecraft. Those are solar panels. The white spike is the radio antenna for beaming back information to Earth. And you can see the booms are stacked along the sides there, packaged for launch. And it had three relatively simple instruments, or suites of instruments, that measured the magnetic fields around the moon and the composition. It was so simple, this spacecraft, that you could say it didn't even really have a computer on board.
Didn't have a computer.
No. It didn't run software like we think it would run software. It had processes and electronic processes that were event-driven and commandable. But otherwise, it's pretty much just turn on and go. And it just spun in orbit. And I think we have an animation if you want to look at that. It just spins in orbit.
Shows it
And there you go.
Yeah,
it just
there it
goes
goes.
around.
That's
and
a very
makes motion.
efficient way of keeping control of the spacecraft as
Yeah,
well.
Oh, the spinning?
The
Yeah.
spinning.
Okay.
Yeah.
Keeps you stable. These instruments didn't have a lot of pointing needs. You didn't point them at the targets. It just went around the moon.
Scanned it.
And a relatively low orbit and made these measurements. And at the very end, like all things that are up, it had to come down, and it
close.
crashed right after about
A hard landing?
it was a hard landing. It was going to crash. It was running out of fuel, but it was directed into a place where there was this excess hydrogen. And the reason they did that was They knew it was hydrogen, but they didn't know the form of the hydrogen. They didn't know if it was the H in H2O. Okay. It could have been the H in OH, or the H stuck onto a mineral, or just protons from the sun. The sun's constantly sending protons into the soil.
And like good scientists and engineers, they wanted to get something more out of this amazing mission.
Exactly.
And they did an experiment. They did the controlled crash of this spacecraft into one of these craters.
Yeah,
that had the hydrogen
into
signature.
Shoemaker crater.
It was on the South Pole.
Yeah, the South Pole.
Okay.
And it had this elevated hydrogen. And the idea there was, we'll crash this spacecraft into it, and as it hits the dirt, it'll splash the dirt up, and that dirt will come into sunlight. Remember, the dirt, where it's impacting, hasn't seen light in 2 billion years. Yeah. So to see it, it lifts it up into sunlight, and then they were going to observe it with the Hubble Space Telescope.
So they're going to point Hubble at the moon at this precise time.
Exactly, yeah. And it all went to plan, it impacted, and Hubble saw nothing.
Nothing.
But you have an experiment, and sometimes you don't know what you're going to see.
Exactly. Yeah, it's not, and it's difficult at the time. It was very difficult to predict what they were going to see. It was the first time they'd ever tried something like this. So just like in the Ranger series, where the first few launches weren't so good, this is the first time they tried an experiment like this.
And why do they think Hubble didn't see anything? What about this didn't work?
Yeah. So. We looked at that, and we looked at that because we were planning a follow-on mission to get at that question: what is the hydrogen?
Again, learning from what came before.
Exactly. And that was a mission that came later, about 10 years later, called L-Cross. And what we did was we learned a lot about what not to do. What this did, Lunar Prospector, it came in very shallow. A grazing angle.
It's in orbit around the moon, and so when it's going to re-enter, it's going to come in at a shallow angle.
And it's not
very
large.
What do you mean by shallow?
Shallow just kind of grazes, it's almost skipping a rock.
Oh, okay.
And it's a small spacecraft, as you saw. It's only about 130 kilograms, 300 pounds.
300 pounds.
And so, again, if you want to make a splash, you throw a bigger rock, right? The bigger the rock, the better. And it was going relatively slow. Because it was in orbit, its top speed was only about 1.8 kilometers per second, which is slow. It doesn't sound slow, but that is slow.
Yeah, you say so.
In space that's slow. Yeah, that's space that's slow. So all those things led to probably a very small splash. So not a lot of material got up, if hardly any. It didn't just have to splash dirt. It had to splash enough of it to get into sunlight so that the Hubble Space Telescope could see it, because it couldn't see in the dark. So that's where, again, the next NASA impactor mission, the next NASA Ames mission to the moon comes in.
Because the 3 out of the 5 lunar missions were managed here at Ames, and this is one of the...
Yeah, this was the first one managed at Ames.
Yeah.
Okay.
Ames is actually quite a leader in lunar research. I just want to mention that my questions are not loading at the moment, so I don't have any questions from the chat for you just yet, but hopefully we'll get those up and running before the end so we can throw you a lot of questions.
Thanks.
So we can put you in the hot seat.
Quiz, questions.
Now, L-Cross, you just mentioned, is a special mission for the two of you, right?
Yes.
Tell us how you were involved.
It was one of Tony's ideas, and I helped build it.
Wow.
Exactly. I had a crazy idea, and I told Kim about it, and she said, yeah, it's crazy enough. It could work.
So what does that stand for, L-Cross?
Oh, no. Lunar Crater Observation Sensing Satellite.
Yeah.
Yes, that's right.
Think what was part of the quiz?
Continuing.
It's not the sport lacrosse.
Okay. Very different.
It's L-Cross.
L-Cross, yeah. Okay.
So, and this was a very special, unique in its design.
Than the other one.
Yeah.
Yes.
And so, if you recall, what I said was bigger rock makes bigger splashes.
Yes.
And so, and it's
the bigger
hard.
rock?
This is part of the bigger rock. Yeah.
Okay.
It takes a lot of. It's very expensive to launch large things into space. So we didn't want to just launch or spend a lot of money, if you will,
and bring a heavy rock with us. So
we used the. This is the upper stage to the Atlas V that launched us to the moon.
Oh, so it's part of the rocket.
Part of the rocket.
That was going to be there anyway?
Yeah.
Okay.
Yeah, it's the one that got us, to leave the Earth system to go to the moon, and it would have eventually fallen back to Earth. It's space junk, but we recycled space junk and turned it into a scientific experiment.
That's right, and
Genius.
and
It's a great idea.
So there's your bigger rock compared to the
That's cool.
140 kilogram impact from
Yeah.
the spacecraft. This is 2,500 kilograms, 2,500,
So about 5,000 pounds.
something like that.
Yeah.
It's,
Okay.
it's like the size of a school bus.
School bus and
School bus.
It's a much bigger rock.
It's a much bigger rock. Yeah, exactly.
So you pulled them apart.
Yeah.
And it's a smart. This is we had some smarts on board too.
And also it came at a very steep angle. It came in at 89 degrees, so it wasn't skipping a rock.
Because we came from Earth orbit and we actually crashed into the moon.
Not to scale.
So not to
scale,
scale, not to scale. But we came in at a very almost 90-degree angle.
Okay.
So therefore we don't have the grazing incidents. We're gonna.
So your rocket hits the moon, and then this little guy.
And the best
looks at
part, we call this the shepherding spacecraft because it tugged this around for 100 days about.
Yeah, 2 months, 2.5 months.
Yeah.
But we had to do that because the upper stage of the rocket contained hydrogen and oxygen, the fuel of rockets, and we're trying to find hydrogen and oxygen water on the moon. So we were just drying it out for 2.5.
Open up the vents and dry it out.
The operators of our shepherding spacecraft, when they tugged, we had this massive weight on the back. Of course, in space it's weightless, but it does affect how much your propellant was. When we separated, that was we've gotten rid of our loads.
Yeah,
we
exactly.
separated?
Much
They were
lighter.
trying to relearn the spacecraft. It was really cool.
Yeah, and so one of the you're talking about the separation. That's one of the best parts actually too. So we had the big rock coming in steep angle with a lot of energy. It came in also almost twice as fast.
Mm-hmm.
We had this shepherding spacecraft. It wasn't just a tugboat, but it had instruments on it, and that's what Kim was mentioning. She was the lead for
like a camera.
Oh, cameras, spectrometers.
5 cameras, 3 spectrometers, a radiometer, and so
It was smart.
It was
Yeah,
smart.
smart.
And it actually observed the impact.
Oh, I think we have a video
Yes,
of it.
it's, the
That's really
impact's
cool.
better than
Yeah.
me doing this. Yeah.
So there we are with a separation, and you can see the Centaur is on its way to the moon. In fact, the moon got in its way, and we're turning the shepherding spacecraft around, and we're following behind. And as the moon got in the way, the impact happened, and we are taking data live stream back to Earth, and 4 minutes behind. So as we flew through the ejecta from this impact experiment, we ourselves, as a spacecraft,
Here we come.
fell right into the moon as well. So all the time the data is live from the moon being streamed back to Earth, and we were commanding all 10 instruments.
You were commanding?
Yeah. Yeah.
Tell us about that moment.
Oh, well, it was very, in 4 minutes of data, and the fact that you couldn't store and, look at it later, it was all coming down in live stream. And we were changing the exposure times of the cameras in real time.
During your 4 minute?
During
Yeah.
our 4 minutes. And this was also happening at 4 in the morning, because, when you're going to do something like this, it always
Gotta be
happens at
early in the
4 in the
morning.
morning. So we had separated from the Centaur about an hour prior, and we were taking data. And as the moon was coming closer to us, the complexity of the scene was starting to have our instruments start getting a little bit overloading.
Mm-hmm.
So we were actually adjusting the gain and exposure times of our camera in real time.
Oh my gosh.
During
And-
4 minutes?
Yeah.
Do you
During-
have 4 minutes to get this?
Yes.
That's it?
And one of my favorite memories from that was the exposure. She knows what I'm talking about. So they're dark craters. You can't see in them. But we had some cameras. We had thermal cameras. We also had one that looks into the near infrared. It's just past the visible wavelengths of light that we see. And the soils in the area where we impacted on the moon are actually brighter in these near infrared wavelengths. So some light scattering off of rim tops goes into the dark craters, and we thought we might be able to image them with our cameras, and for the first time get an image of the floor. And this was a risky thing. We wanted first and foremost just to get good images of where we were impacting the plume and so on. But about 3 minutes in or so, Kim and I decided, let's change the exposure.
3 minutes into 4 minutes.
Yeah, exactly.
Yeah.
Seriously.
And so
We were just going to.
and we didn't control it. We had to call in the request to command, who then had to get approval from flight. So, there's process, right?
Yeah.
Okay.
And of course, we had lots of cameras. We have 5. These are the near infrared cameras we want to change, NIR. We also had mid-infrared cameras, MIR.
Different camera.
Different camera.
camera.
Kim calls in, change near IR1 exposure to 3. Command, copy, MIR1 exposure 3. No. NIR. This goes on
This
like
is N versus M.
exactly. This goes
It's a matter of, we're going to hit
the moon is getting really big.
It was really.
So finally, it goes on a couple more times. Finally, Kim screams, November!
Instead of Mike, the alphanumeric.
Yeah, and he got it.
got
Then
it.
Command goes, NIR1. And then he made the change.
Wow.
And
In time.
In time. And
In time.
we have a video here that shows those images. Those are still the only images of the impact site that we've gotten from it. And they're beautiful because it actually showed the crater we made.
Yeah.
And you could see it, and we measured it. It was 30 meters across.
Wow.
And we're looking in these permanently shadowed regions, the regions that don't have any sunlight, and we're looking at it in the infrared because we can get the scattered light off the crater walls, but then we also were able to measure the thermal signature, the heat from the impact.
Yeah.
And we're able to find the
Nice.
crater we made.
Oh my gosh.
It was a really neat experiment. It was a really fun project. to work on.
Yeah.
I have a question here from the chat. Could setting up a telescope in a dark crater on the moon be beneficial to astronomy?
Ooh, I'll let the astronomer take that one.
Absolutely. Actually, having a telescope on the moon in general would be wonderful because you don't have the atmosphere in the way. And the atmosphere prevents us from seeing a lot of light. In fact, telescopes on the ground are really restricted to 2 wavelengths, the visible, what our eyes can see, and also the radio that can transmit through our atmosphere. And having a telescope anywhere on the moon would allow us to see a whole range of light. Now, if you were in the permanently shadowed part, you have to, deal with technicalities of how you keep everything warm because it's also very cold there.
Your equipment.
And from using a telescope to look at things in the universe, you just have to stay away from having when the Earth comes into your field of view, it's a nice bright reflected ball because of the sunlight reflecting off the Earth. And of course, you don't want to look at the sun, but you can look at the universe from there or anywhere on the moon.
Very cool.
Yeah, I think it's.
So, I don't know if you had a question, but I want to know what this thing is all about. Okay,
Yes,
so
I'm curious.
getting
Seeing this.
back to L Cross, which you crashed into the crater.
Yeah.
See what was in that debris. Okay, I know that a month after that, there was a press conference, right?
Yeah.
And you turn up with a bucket, right?
Yes.
Okay, we have a photo of that. Younger Tony with his
Younger
bucket
me,
at the
10
press
years ago.
conference. There he is.
I don't age very well, I don't think. I'm sorry.
Oh, nonsense. So tell us what's going on there.
So, the unfortunate thing about an impact mission is it comes to an end very dramatically, and everybody wants to know, well, what'd you see? This is actually our second press conference. Kim and I had to prepare for a press conference 1 hour after the impact. So at 5 a.m.
Pacific, which is 8 a.m. East Coast time.
Oh, yeah.
So that was the first one. Then
Nice.
1 month later, after working, basically the entire team working 24/7, we came to a unanimous decision to go forward with the results, which was we found water. And it was not a small amount of water. It was a significant amount. And I was talking with my wife, actually, about how to convey this, because I could talk, it was 5% by weight, or it was, 1,342 kilograms and a 30 meter.
What's that mean?
It was, exactly.
And you're like 5% by weight, whereas water in the Sahara deserts on Earth are 3% by weight. So we did sort of hit a relatively dry, but still has a lot of water.
The moon pretty wet.
It's
right?
wetter,
Yeah.
so wetter than the Sahara Desert.
Wetter than the Sahara
About,
desert.
about as wet. Yeah.
It's even comparable to Earth. That's pretty crazy.
Yeah, it is,
Yeah.
isn't it? Yeah.
So we
Amazing.
were,
Yeah, and so my wife said, "Why? Well, how many buckets is that?" I'm like, "Buckets." She's like, "Why don't you just get a bucket and say I got this much water on the moon?" I said, "Okay, I could do that." So we got a 2-gallon bucket, and in that press briefing, we said we found not a small amount, we found a significant amount, and actually. In the little hole we made, teeny little hole we made, we had 150 of these 2-gallon buckets, or I forget the exact number at the time. So that's the origin of the bucket, and I think it made a good point. And that's actually really key. And the other thing that I like about using the bucket was L-Cross was not a science mission. It did fantastic science, but it was not a science mission. Its purpose, it was actually supported and funded through the Human Exploration Office in NASA, not the science mission. Its purpose was to understand that hydrogen as it related to a potential resource.
Okay.
Could we use the hydrogen on the moon for making water, for making rocket fuel.
Making fuel.
And that's the most important one. It takes a lot of energy to lift anything out of the gravity well of the Earth.
Using resources right there, right on the surface
Making
of
it
the
here, bringing it up is not efficient.
That's not efficient. If you can make it there, you're saving a 90% of your fuel need, because you spend 90% or so of the fuel just to get off the Earth.
And Alcross just sampled one tiny place and had buckets of water, and all those images from the predecessor orbiters that showed hydrogen signatures in many, many craters on both poles. There's a lot of resources there.
Yeah.
So the anniversary of that was Tuesday?
Yeah,
It was
2 days
last
ago.
Tuesday, 9
October
years
9.
ago.
Yeah, 9 years ago.
And we're still writing papers on it. I mean, it's 4 minutes. All the data could fit onto a circa 2009 thumb drive, and then have plenty of room left over.
Yeah, and it's also changed the way we were looking at the moon now.
Completely.
It really has, changed the way.
And that's actually a really good point. The last thing I'll say about the results. Well, so there are significant results out of Alcross that we reported at that meeting was we knew the form of the water, or the hydrogen. It indeed was, at least
Part
in
of
part,
H2O.
was water, and we know now is water ice. We knew there was enough to be a potential resource for in situ resource utilization, and those were the two big questions. And the third thing was unexpected. We saw lots of other things besides water.
Yeah, it's almost like these permanently shallow craters are garbage heaps of the solar system. There's a lot of treasure troves
Who
there.
said that?
I don't know who
I
said
think
that, but it's maybe it's not a very colorful
Resource
image.
heavy.
Resource heavy.
That better way to put it.
And we're all into recycling too. So here are ways you can reuse things that have been coming.
And other things were like carbon dioxide, hydrogen sulfide, mercury,
Should we use those
sodium.
things?
sodium, argon.
Yeah, some of these things you can use. Some of these things you want to avoid. Like if you mine the water for drinking, you better get rid of the mercury. And so, but it's very interesting from a science standpoint. So from a resource standpoint, yes, interesting. But from a scientific
Where did it
standpoint,
come from?
this says something about the origin of the water, and then therefore says something about the history of the moon and the Earth and all the inner planets, inner solar system planets. And so it's really was an amazing finding from Alcross.
Yeah, I mean, the moon is a laboratory, and it's a time machine back to what had happened back then and what's been happening since. The last
That
several billion
water
years.
and those other species have been there for at least 2 billion years.
So we found the water.
Yeah.
And now we followed up. There's another mission. We said there was 3 out of the last 5. What was
Yes.
that third one?
So we'll get rid of this guy.
And
here.
to warn you, I've got a bunch of awesome questions, so.
Okay,
you
good.
want to throw a question while we get them on?
Okay.
So Tony was talking about how we found all these other things in the basin of this crater, this one place. And you naturally ask more questions. That's the beauty of these missions. You find a discovery, but you're like, where did it come from? Did it come from within the moon? Did it come from things hitting the moon, bringing it, like comets or asteroids? Or, is it from the atmosphere around the moon? So that led to the next mission.
The next mission, LADEE,
which stands for
Lunar Atmospheric and Dust Environment Explorer.
Yes, you got that right. Another quiz continues.
another quiz of the acronyms of NASA.
It's hard.
Okay, so this is LADEE,
Yes.
and
This was
it looks different.
what was its
too.
goal?
managed by Ames, spacecraft built by Ames, one of the instruments I led built here at Ames.
Which was a daughter instrument from the Alcross mission.
Exactly.
We like to build upon our knowledge of what we've learned before.
Exactly, and that's key. That's really important.
So LADEE was looking at.
It was looking at the atmosphere of the moon.
Okay.
We call it an exosphere. And so an exosphere is an atmosphere where the molecules in the atmosphere never come in contact with each other. They're very lonely.
Oh,
They
sad
just,
lonely
They
molecules.
just bounce around and they never run into each
So
other.
it's so thin that there's just
So
not enough to touch each
exactly.
other. Okay.
But it's important because, as Kim was saying, it says something about how the surface of the moon interacts with its environment, the space environment. And there are numerous other bodies like Mercury, the moons of Mars, the outer moons of Jupiter, Saturn, icy moons, that have these what are called surface exosphere boundary conditions, where they are interacting with space, and how they interact with micrometeorites, charged particles, etc., says a lot, or governs a lot of how they have evolved over time.
So this mission is designed to basically sniff the atmosphere.
Sniff the atmosphere. I think
Sniff the exosphere of the moon.
exosphere.
It's a big technical term.
And I think we have an animation of how it kind of went about sniffing.
Yeah. It also, if you read,
Whoa.
now it shows it spinning here, and it's got panels on all sides, like Lunar Prospector did, but it actually had very fine pointing capabilities. It had to point its instruments in all different directions. Mostly my instrument. I was the real pain in the
And it's barnstorming the moon. It's
and it had to fly
really
low. So one of the really interesting questions that Laddie addressed comes from Apollo, actually, and Surveyor. The Apollo astronauts thought they saw something that looked like scattered light from dust being elevated off the surface of the moon up to tens of kilometers above the surface. And there's these images from the Surveyor landers that show dust near the horizon at sunrise and sunset. So there's this question, is there elevated dust around the moon near the terminators where you go from light to dark? Laddie had a dust detector and flew very low, just under 40 kilometers above the surface at the
Sniffing
terminator,
around.
trying to sniff out that dust and other species. And one of the really important findings is it didn't see it.
So the
concluded-
astronaut saw it, but Laddie didn't saw
Laddie
it.
did not.
see it.
Yeah. And robots are never wrong.
But humans can be.
I would never say that to an astronaut. No.
So
no,
what were the astronauts seeing?
It could be zodiacal light. They undoubtedly saw scattered light. It's the question is, where did it come from?
Yeah. And zodiacal light is light from our sun scattering off the dust in the plane of our own solar system, the remnants of our
Okay,
of
so
our
not
solar
coming.
system.
It was dust, just wasn't from the moon.
Yeah, exactly. Yeah,
It's
yeah.
just a background light
And
in our
there
local
could
solar
still
system.
be dust down low. We didn't get that low. The Surveyor dust could be just meters above the surface. To this day, though, Jack Schmitt, one of the astronauts on Apollo 17, really does contend that while there was dust, it wasn't on rock. So he's really of the opinion that this elevated dust is not there.
Okay. Well,
So we still have more questions. We need to go
Yes,
back,
many more
right?
questions.
Because
We
we
do.
have tantalizing evidence or non-evidence
Yeah.
of things, you know?
Yeah,
I also have questions.
Yeah.
Oh, more questions, okay.
I suggest we forge ahead into
Yes.
our next segment, which is rapid fire questions. So let's roll the segment. All right, you asked for it, so here we go again. It's time for rapid fire questions where we cover as many from the chat as we can. So, quick answers, lots of questions,
Quick.
and then
Quick.
we're going to get
I
to
don't know,
the
quick.
the future after some questions. So there are a number of questions about exploring caves on the moon. Are there plans to do this? People have heard about suggestions of building colonies in those caves to avoid solar radiation. Any plans to explore caves?
From NASA? Potentially. So
I think it'd be a great idea.
It is. Yes. So absolutely very interesting places. There are some commercial companies that are very interested in these locations as well. And NASA is now working very closely with commercial private sector companies who are going to be providing lunar services to the moon. And eventually, yeah, we're going to definitely be exploring those caves. There's a number of projects working on the technologies, methods, and whatnot for exploring those caves.
And the questioner was right about going beneath the surface to get away from the radiation. We're protected here with our magnetosphere that protects us from the space radiation that's coming mainly from the sun. Out in the moon, you don't have that exposure, but you can use rock or water as a shield.
Oh, yeah.
So, yeah, a cave is a lovely good
Caves
idea.
have potential.
Yeah.
Okay. Here's a cool one. What do your guests personally think is the most interesting mystery about the moon? What would you love to solve?
You first.
Oh, me.
Yeah.
Well,
I gotta think.
we had NASA had this mission called Grail that had two satellites, ebb and flow. And they flew around the moon, and they were to measure the. They wanted to look at the interior of the moon because we were wondering why, it's a little bit lopsided in terms of its surface and where its gravity is. So it gave us the first map of the gravity of the moon, and it's still kind of asymmetric. And so I think that's one of the interesting mysteries of the moon. It comes down to its origin. Again, we don't know how the moon formed, but we can see its signatures 4.6 billion years later,
Yeah.
and try to work
amazing.
out, be that detective.
Right, the things you can work
But
out.
I think
amazing.
the gravity field of the moon is intriguing.
Cool.
For me, it's the water.
Oh, yeah.
We know there's
Wow.
water, but we don't understand why we see it, where we see it, and why we don't see it where we think we ought to see it. Mercury also has water at its poles, and it is where you expect to find it. It is in where the models say that it has these permanent shadowed craters too, because it has no tilt to its axis, very little tilt, and it behaves. I always like to say Mercury is behaving itself. The moon, that crater is plenty cold, but it looks
still water.
It's
it
dry.
looks dry.
It's dry.
Oh.
The crater
So
right next to
it doesn't fit.
is cold and does have
Yeah.
water. So that is an ongoing mystery right now, is the history of the water on the moon. Where did it come from? And this is very relevant for utilizing it, because you need to understand where it is to be able to access it at the scales we need to access it.
Okay. Quick question. Can you build houses with moon dust? Think we could use that as a resource?
Yes. Yeah. They can sinter. There's a lot of projects going on right now where they are developing the techniques to sinter, basically heat it up and form it into bricks.
Yeah. Or like ceramics.
Ceramics,
wow.
yeah.
Moon ceramics. We'll open up a shop.
Okay, cool. We have like 5 minutes left, and we also want to talk about future missions, which is one of the questions. Do we have any named missions gearing up to land on the moon? I know Ames has some instruments that we're building to study the moon, but how would you guys talk about the future?
So,
Lunar
right.
exploration.
There is Space Directive 1, which
From the president, yeah?
from the president, and he established the Space Council to see it enacted. And what it does is it gives direction to NASA to reestablish a presence on the moon in a sustained way. So it's not just, as our administrator says, it's not about flags and footsteps. It's about a sustained, permanent presence on the moon. So right now, NASA is building that plan to do that, and it's coming together right now and formulating right now. One of the big differences between what we're doing now and what we've done in the past is the involvement of the private sector and commercial companies. We routinely use private rockets to launch our hardware. Now we're talking about using private landed services to bring payloads to the moon for NASA. It's a whole new paradigm.
And we shouldn't ignore that the space between the Earth and the Moon is also very special, because there's designs in place for what they call it the cislunar highway. A way
to
it's
the moon.
or a cislunar gateway.
Yeah,
I feel like I'm
gateway.
babbling fiving or something, but it's like a gateway that it's a place where you have to we were talking earlier about getting to the moon is one part of that evolution of leaving the Earth and getting to the moon. But if there's ways to be efficient to refuel your modules, that will help add to the sustainability of a
Yes,
long-term presence.
absolutely.
So there's
And-
infrastructure.
And here at
using the resources
And you can
there.
put a telescope there, too.
and you put telescopes there.
I put
yeah.
a telescope there.
Says the astronomer.
Telescope there.
And here at Ames, we're actually two things we're working on, or two instruments that are going forward are prospecting instruments. They're instruments that are used to look for water on a rover at the scales, what I call the human scales, the scales at which we would utilize it. One's a neutron spectrometer and one's a near-infrared spectrometer, and these are the bloodhounds that would go on a rover and characterize an area for the water form and concentrations and distributions, the things you need to know to establish whether or not, how you're going to utilize it.
Okay.
Yeah.
That's
And-
something
and-
you tested here in California, right?
Yes,
Yeah, I think we have
tested
video of
this.
that.
Yeah, we have footage of the
So
rover.
this is on the K-Rex rover here at Ames. And on it are the two instruments. That black skirt there, we called it the skirt, keeps the sunlight out. We don't like the sun because it's looking through the atmosphere. It's built for the moon. These instruments are built for the moon. The sun carries other signatures on it.
So
And
where
our,
is this
and our
tested?
neutron spectrometer is like a granddaughter instrument from Lunar Prospector.
Yeah.
And the infrared spectrometer is a granddaughter instrument from L-Cross.
Outcross, yeah.
You keep saying that today.
You know,
like
we
we're
learn from
building on.
we're building
Build
on the
on.
knowledge that we have passed.
And this is in the Mojave Desert.
Okay.
So
Yeah.
that's why it's, again, water concentrations there are not too far different from what we see.
Dry in the desert.
It's pretty dry, exactly. And we are learning there in this that's called an analog field test, where you're trying to test something that's analogous to how you do it on the moon. And there we're learning how to use the data real time to make decisions about where to make additional measurements, where to prospect to best characterize the distribution of water.
When you say prospect, like we like the gold rush, the miners
Absolutely.
prospecting for
Exactly.
gold,
Absolutely.
prospecting.
And you know,
Okay.
and
It's the
if you
same
think
thing.
about how those gold mine, they were trying to find
Panning
gold,
for gold.
and they don't find anything. They go to another place and they try again, and they go to another place. Found the gold, and that's where we'll set up shop for the.
But instead of gold, it's just
Water.
a water.
It's water.
It's water, and the rovers are going to go first and scope it out for us before we get there.
Yeah,
right?
well, it's exactly as you saw earlier with the Surveyor imagery with Apollo in the background. Yeah, the robotic precursors, they're called, go there to survey it, to understand it, and then you bring in the more valuable assets following the robotic surveys. Yeah.
We have a little animation showing what a
Oh, yeah. So we've
Prospector rovers
studied
might
this
look
a
like?
lot here at NASA Ames. We built synthetic lunar terrains and rock yard tests. So over the past really 4 years, we've been studying this heavily, along with collaborating with partnering with a lot of other NASA centers. And this just shows what a prospecting rover would look like as it drove up to a permanently shadowed crater.
so it'll have that light.
They'll have a
spotlight?
light. We've got to look in there somehow. This particular design uses cameras for navigation, so you need to bring light. There's other variant that could use LiDAR, lasers that you wouldn't need the light.
And rovers
Wow.
are all part of this evolution of exploring new worlds. You start with your flyby, then you have your orbiter, then you land like the surveyors,
Right.
and then you bring the rovers.
And you get the mobility.
You get mobility,
That's key.
and you get to explore.
Yeah, step by step building up
Yeah.
that ability, right?
Yeah.
Cool.
Oh, that's just about all the time we have, sadly, but this has been awesome. Thank you for your stories and expertise.
Well, the future is very bright for lunar exploration.
It is.
We still don't know much about the moon, even though we've been studying it, and we're always surprised by what we find. And we seem asking a lot more questions than we asked before.
Yeah.
As it should be, right?
That's the beauty of science and exploration. There's always more. And the amazing thing is if you look at how we think about the moon now with the water cycle. We talk about a water cycle on the moon. Now.
No one ever said that.
Now,
You know?
yeah. Now you know.
Now there's a
they
water
used to say
cycle.
this is not your grandparents' moon. This is not my father's moon. This is, and I know in another 10 years we're going to be looking back and going, wow, we didn't know that.
We know that.
Yeah.
So much to discover.
More treasures.
Yeah, well,
to be
thank you for
found.
joining us, both of you. It's been great having you here.
Thanks for having us.
thanks.
It's fun.
So this has been NASA in Silicon Valley Live, a conversational talk show out of NASA Ames Research Center with the various scientists, engineers, and researchers, and all around cool people at NASA, where we talk about the nerdy NASA news you need to know about. If you like that, you can find us on Twitch, YouTube, and Facebook, and we're also on NASA TV. And if you didn't catch us live, we'll be on video on demand after the show is over. You can also catch the audio version on podcast services. So a huge thanks again to our guests, Tony and Kimberly. We'll be back
Thank you.
on October 25th when we talk about when we have a NASA-themed Halloween costume contest and cosplay contest. So until then, we'll see you next time. Bye.